torsional equivalent system of multiple shafts. So we'll see how the equivalent system is calculated. This is a equivalent mass moment of inertia. This is one rotor which drives to another rotor. The speed of first rotor is n1 and the speed of second rotor is n2. For converting the equivalent system, the speed of both a rotor is considered as a first rotor, that is n1. Now the total kinetic energy of two systems is conserved or same, so we can write half of bracket start I1 omega 1 square plus ha plus I capital G omega 1 square plus I small g1 omega 2 square plus I2 omega 2 square bracket close. But theta 2a upon theta 1a is equal to omega 2a upon omega 1a is equal to n2 by n1 is equal to n, which is a speed ratio. Replacing now omega 2, we can write half of bracket start I1 omega 1 square plus I capital G omega 1 square plus I small g1 n omega 1 to the square plus I2 n omega 1 square. So after this we can write half of bracket start I omega 1 square plus bracket start I capital G plus I small g1 n square bracket close omega 1 square plus I2 n square into omega 1 square. This is equation number 1. Now the kinetic energy of this system, equivalent system, considering speed n1, we can write, or omega 1, half bracket start I1 omega 1 square plus IgE omega 1 square plus IE omega 1 square bracket close, which is equation 2. After comparing equation 1 and 2, equivalent mass system, mass moment inertia of gear IgE is equal to I capital G plus I small g1 into n square. Equivalent mass moment inertia of disk will be IE is equal to I2 into n square. Now equivalent shaft torsional stiffness. Now total potential energy for two system will be same. So half into bracket start K1 theta 1 A square plus K2 theta 2A square bracket close. But again, theta 2A upon theta 1A is equal to omega 2A upon omega 1A is equal to N2 by N1 is equal to N. So replacing theta 2A, we can write half into K1 bracket start K1 theta 1A square plus K2 theta 1A square N square bracket close. This is equation 3. Total potential energy of the equivalent system, we can write half into bracket start K1 theta 1 A square plus Ke theta 1A square bracket close. This is equation 4. On comparison, equation 3 and 4, we can write equivalent shaft stiffness K is equal to K2 into N square. Now individual shaft is the two individual shaft having a speed, two different speeds. So two shaft having two different speed, N1 and N2. This speed of N1, this is N2. So equivalent shaft system can be written as, considering both shaft speed is n1, equivalent mass moment of inertia of gear is equal to Ig plus Ig1 into n2 by n1 to the square. Equivalent mass moment inertia of disk 2 will be I2 plus I2 into n2 by n1 to the square, and equivalent torsion stiffness of shaft 2 will be K2 into n2 by n1 square. So hope you have understood about how equivalent system for mass moment of inertia and shaft stiffness are calculated. So thank you for watching.